and suppose we have x is given, and we map it to the y through this fx function, and through this y to x we can obtain through this inverse function. So the domain of f inverse is the range of domain of this is the range of this fx. Similarly, the range of f inverse x is the domain of this fx. So it is important to remember that not every function has an inverse, and the inverse function can exist if and only if the function f is one-to-one mapping. Inverse is only exists if the function is a one-to-one mapping. This is very, very important point. Now this exercise 1.6, we have fx is equal to x plus 5 square minus 7 for f is greater than this. Find an expression for f inverse x. And for this we have this x is equal to x plus 5 minus 7, x is greater than 5. Let y is equal to x plus 5 square minus 7, and then we take this y 7 on the other side, and x plus 5 square is equal to y plus 7. X plus 5, we take the square root on both sides, and x is equal to 5 plus 5 y plus 7 under root minus 5, and this x is basically the f inverse, because from this function we have obtained this x. So we will write this variable x here, and we replace this x with f inverse x. So this is the first part. Move to the question number 5, that is that we have given f is x to 5x minus 3, and g as a function for x to 7 by 2 minus x for x is not equals to 2. Express f inverse x and g inverse x in terms of x. So f x 5x minus 5, this, so fx is equal to 5x minus 3, y is equal to 5x minus 3, x is equal to y plus 3 upon 5. F inverse is replaced with this, and this x, y with x, so this is f inverse. Similarly, for the g inverse, we will take this value. So let y is equal to this, and we take this y on the other side, and from this x we write it g inverse x, and this is 2x minus 7 with x. So this is very simple one. Let's move to the question number 8. Okay, 7. Question number 7. We have this x minus 4 square plus 5 for x is greater than. Find an expression of f inverse x and solve the equation f inverse x is equal to f0. So let's solve the question number 7, which is important. So here we have this fx is equal to x minus 4 square plus 5 for x is greater than 4, and f inverse x, we have to find the f inverse x, and in the part B we have to show that f inverse x is equal to f0, and we have to solve for x. So let's for the inverse x inverse, fx inverse, so let this function is equals to y, x minus 4 square plus 5. So x this 5 may be placed there and take the square root on both sides, then x minus 4 is equal to under root y minus 5. So x is equal to under root y minus 5 plus 4. This 4 we move this side, we can shift it write down as f inverse x, and this y is replaced with x minus 5 plus 4. So this is f inverse. So f inverse is obtained this. Similarly, for this function we place 0, f0. On placing this 0, it becomes 4 square plus 5 is 21. So this is 21, and this function is equals to this. So this is equals to this 21. So now solve this, and on solving we have obtained x is equal to 294. This is very important. Let's move to question number question number 11. here we have f function is 2x plus 8 divided by x minus 2, and here we have g function x minus 3 2 for x greater than minus 5. So f inverse fx is equals to g inverse x. So we have to find this g inverse x is equal to first g inverse x. So this is this equals to y, and this 2y is equal to x plus minus 3, and x is equal to 2y plus 3. So this is g inverse, and we know that g inverse is equals to fx. So this is g inverse and this is fx, and on comparison we have obtained this. So this is x equal to minus 2 and x equal to 3.5. So we have this solution, and let's solve this question number 13. Let's solve this question number 13. We have fx x plus 6 for x is greater than 0. G is x tends to x under root for x is greater than 0. So express x square minus 6 in terms of f and g. So we have to express this in terms of f and g. So this is question number 13, which is important. Fx is equal to x tends to x plus g, and this g is x under root. We can see from x to x, for we have to write the function that shift this to this value. So we know that this is equals to y. We set this y, and then this becomes x square minus 6. So x square is equal to y plus 6. Take square root on both sides, and so we have this y plus 6. So this y plus gfx is basically the inverse of this. So this is equivalent because this is x, and in place of this f we can write here x plus c. So this is gfx, but that is the inverse of this one. So as a result, this is gf inverse. So gf inverse, so that's why we can write down f inverse and g. So this is first and this is second. We usually write this. This is very important question. This question number 13 is extremely important from examination point of view. So the next session we will discuss